I welcome you to the course Introduction to 3D Printing. As every designer knows, there is magic in transforming a great idea into a tangible and useful object that you can hold in your hands. It can be a consumer good on a store shelf, a critical compound of an industry, or even an early physical prototype that unveils your new idea to the world. Let us get introduced to 3D printing. Since the Industrial Revolution, manufacturing has been synonymous with factories, machine tools, production lines, and economies of scales. So it is surprising to think about manufacturing without tooling, assembly lines, or supply chains. 3D printing is a form of additive manufacturing technology where a three-dimensional object is created by laying down successive layers of a material. Today you can see many parts, appliances and tools in a wide variety of materials right from your home or workplace. Using a computer, simply create, modify or download a digital 3D model of an object. The basic principles include material cartridges, flexibility of output and translation of code into a visible pattern. Let us have a look at the evolution of 3D printing. As 3D printing technology evolved, it started to be used to manufacture goods. The technology for printing physical 3D objects from digital data was firstly developed by Charles Hull in 1984. He named the technique as stereo lithography and obtained a patent for the technique in 1986. While stereolithography system had become the popular one by the end of 1980s, other similar technologies such as fuse deposition modeling and selective laser sintering were introduced. In 1993, the Institute of Technology, that is MIT, patented another technology and named it as three-dimensional printing techniques. This technique is similar to that of inkjet technology used in 2D printers. In 1996, three major products, Genesis from Stratasys, Actra 2100 from 3D System and Z402 from Z Corporation were introduced. In 2005, Z Corporation launched a breakthrough product named Spectrum Z510, which was the first high-definition color 3D printer in the market. Another breakthrough in 3D printing occurred in 2006 with the initiation of an open-source project, which was aimed at developing a self-replicating 3D printer. What terminologies are used in 3D printing? 3D printing is providing a platform for collaboration that is accelerating innovation and disruption in the material world, just as the Internet fostered collaboration, innovation and disruption in the digital world. Additive manufacturing, rapid prototyping, subtractive processes, stereolithography are some terminologies of 3D printing process. Let us discuss the meaning of each terminology. We made several pivotal technology decisions to achieve that, speed the goal. First, we based our additive fabrication technology on high throughput inkjet printing. Additive manufacturing refers to technologies that create objects through sequential layering. The creation of solid object without the use of conventional tooling, usually directed from a CAD model or other digital information. Virtually all methods utilize a layer-by-layer approach. Second is rapid prototyping, which is a group of techniques used to quickly fabricate a scale model of a physical part or assembly using three-dimensional computer-aided design, that is CAD data. Affordability is one of the most important factors in making rapid prototyping accessible to everyone. With the low cost of operation, you don't have to consider the cost of each model you produce any more than you worry about the cost of each sheet of paper you print on a document printer. Subtractive processes. Subtractive processes removal of material by methods such as cutting or drilling. Subtractive process are the traditional manufacturing processes which are generally use a subtractive approach that includes a combination of grinding, forging, bending, molding, cutting, welding, gluing and assembling. Take the production of a seemingly simple object, such as an adjustable wrench. Production involves forging component, grinding, milling and assembling. Stereolithography was defined by Charles W. Hull as a system for generating three-dimensional object by creating a cross-sectional pattern of an object to be formed. Stereolithographic 3D printer position a perforated platform just below the surface of a vat of liquid photocurable polymer. A UV laser beam then traces the first slice of an object on the surface of this liquid, causing a very thin layer of photopolymer to harden. The perforated platform is then lowered very slightly and another slice is traced out and hardened by the laser. Another slice is then created and then another until a complete object has been printed and can be removed from the vat of photopolymer drained of excess liquid. This is for today. See you in the next session.